I am Dr. T. Vijaya Gowri, working as Associate Professor in Department of Civil Engineering, B.V. Raju Institute of Technology, Narsapur. The course name is Railways, Airports and Harbour Engineering, and topic name is Airport Subsurface Drainage Design. Overview of today's session is functions of subsurface drainage, design of base course drainage, design of subgrade drainage, intercepting drains, types for drains, filter materials. First, we see what is the need of subsurface drainage. Here we see functions of subsurface drainage: to remove the water from the base course, to lower the groundwater level in the subgrade beneath the pavement, to intercept, collect and remove the water flowing from the adjacent spring on pervious strata. So, now we are going to see base course drainage design. So, what are the conditions made that necessity of providing subgrade drainage or base course drainage? So, here base course drainage is normally required the following conditions: where the frost action occurs, the subgrade immediately beneath the pavement happens. During the thaw, the water is going to be rising like this and it will come beneath the pavement surface. This water is going to be drained, the side drains through the side drains. So, if you are providing inadequate drainage, then the base course becomes saturated, and lose its strength and cause the failure of the structure. So, base course drainage, when groundwater level may rise to the bottom of the base course because of the capillary rise. When the ponding on the surface runoff on the pavement may occur because of the impervious nature of pavement and base course. So, because of the low permeability, the ponding action can be taking place on the surface of the pavement. So, we need to provide base course drainage the side of the pavement. Here, they provide base course drainage when subgrade has coefficient of permeability is less than 3 into 10 to the power of 6 and 3 into 10 to the power of 7 for 2.5 to 7.5 meters depth, and 3 into 10 to the power of minus 8 when greater than 7.5. There is a relation between the depth of the groundwater and coefficient of the permeability of the subgrade. The depth keep on increasing, the permeability is going to be reducing. The subgrade drainage is also required when groundwater level in the subgrade may be raised to the depth less than the 0.3 meters below the bottom of the base course. Intercepting drains are required when the seeping water in the subgrade rises the ground level locally and generally to within 0.3 meters from the bottom of the base course. Now, we are going to see the design of base course drainage. Before going to design, we can see this picture. This is the base course drainage is provided here. This is the pavement and this is the base course. So, this half portion of the pavement half section of the pavement has been given here. So, here the subgrade is impervious and here this is the filter material, this is a drain and this is the cushion, 15 centimeters cushion. Here they provided impervious layer to avoid the percolating the rainwater through this particular point. So, some of the assumptions are made in design of base course drainage. The first one is base course is saturated. No inflow is coming during the drainage base course. Subgrade is impervious and then base course has free outflow into the base drain trench. So, now we see the steps involved in design of base course drainage. The first step is determine the coefficient of horizontal permeability of the base course material by laboratory tests. So, average value of coefficient of permeability for remolded samples of sand, gravel type or base course materials have been given in this particular table. So, coefficient of permeability of remolded sample, they are comparing with the gravel material and which is passing through that CV number 2200, then the percentage of weight, the weight is given. So, the percentage of passing keep on increasing, the gravel size, the size of the particles keep on increasing. So, that means the permeability is go on reduces. Next step is compute the average coefficient of horizontal permeability where more than one base course material is used for that particular base course. So, this is the formula for providing the average coefficient of horizontal permeability. Kb is equal to K1 D1 plus K2 D2, K3 D3 plus so on Kn Dn divided by D1 plus D2 plus D3 so on Dn, where Kb is the average coefficient of permeability, K1 and K2 is the individual coefficient of permeability for different layers of base course, and D1, D2 are the thicknesses of the respected base course layers. So, next step is compute the maximum rate of seepage from the base course into the base drain from the following equation. Q is equal to KH into H0 divided by 60D, where Q is the maximum drainage in cubic meter per minute per meter length of the drain. K is the coefficient of horizontal permeability of the base course in meter per minute. H0 is the vertical difference or level difference between the upper portion of the base course at center of the pavement to the lower portion of base course at the end of the pavement. So, here H is the thickness of the base course and D is the distance of the half of the pavement section. So, compute the time for 50% drainage of the base course from the following equation. T50 is equal to N0 D0 divided by 2880 K into H0. So, T50 in time in days for 50% drainage, N0 is the efficient porosity of soil is given from this. So, degree of drainage is defined as the ratio of percentage of volume of water drained by given time to the total amount of the water that is possible for given material and diameter of the pipe. So, provide drain spacing 2D to achieve 50% of drainage of the base course in 10 days or less. If it cannot be done with reasonable drain spacing, you have to go for the more pervious base material or thicker base course. Knowing the value of Q and the diameter and the slope of the drain can be obtained from the Manning's formula. So, if you want to provide the diameter, if you want to identify the diameter of the pipe required for the base course drainage, then equate that Q is equal to Q for the Manning's formula, that is A into RH 2 by 3 slope to the power of half divided by N. From this we can calculate the diameter of the pipe. If you decided the diameter of the pipe, then you can also find out what is the slope of the ground or gradient is to be provided. Here A is the area of the pipe, RH is the hydraulic radius, that is hydraulic radius is equal to A by P. A is the area of the pipe, P is the wetted perimeter, S is the slope of the ground or gradient and N is the coefficient of roughness. So, usually 15 centimeter diameter is provided. So, provide minimum thickness of filter material around the drain pipe to be provided. The cover should also be provided for sustaining the wheel loading. So, next is design of subgrade drainage. Here we can see the pavement, and this is the pavement, this is the impervious cover, and this is the turf we are going to see. So, the drain is placed over here, and this is the water table because of this lower because of the place in the subgrade drainage. So, before going to know the steps involved in design of subgrade drainage, we have to see the assumptions made. So, first one is the subgrade below the groundwater level is saturated. The groundwater level beneath the shoulder is raised by infiltration through the shoulder. Drains have adequate capacity and subgrade is not under the artesian pressure. Steady flow conditions exist. The steps involved in drainage design. Here, compute the maximum rate of discharge from the following equation. Q is equal to KHC divided by 60. Q is the maximum discharge in cubic meter per second per meter length of the drain, and K is the horizontal permeability of soil in the shoulders in meter per minute. H is the thickness of the soil being drained in meter. C is the shape factor, depends on the length and height. So, the thickness of the ground layer, H is in meter, is in vertical axis, and shape factor is in horizontal axis, and L, there are the two curves have been given, that L is equal to 7.5 meters, L is equal to 15 meters. So, when K is equal or less than the 3 into 10 to the power of minus 4 meter per minute, then use the curve having L is equal to 15 meters. So, the slope or diameter of the sub-drainage pipe can be determined by using the Manning's formula. Then you can equate with the Manning's formula and find out the diameter or slope from the equation. So, usually 15 centimeters diameter pipe is adequate for subsurface subgrade drainage. The recommended minimum slope is 1 in 650. Next, placement of subgrade drain, where we have to place the drainage pipe. It should be placed at a depth of not less than the 0.3 meters below the base course. And it is also should be provided at least not less than 0.3 meters below the groundwater table. At sufficient depth to be provided, adequate cover required for the stability to be provided here under the drain for the stability under wheel loading. Locate drains at the outer edge of the paved areas, except if the large areas like parking aprons or any big areas is covered with the impervious layer, then we have to provide intermediate of the in between the paved areas. Next, intercepting drain. So, this drain is placed where the seepage is more. To collect the seepage water, we have to place the intercepting drains. This intercepting drain, the top layer should be pervious, this is closed by pervious. Whatever seepage is coming from the one side to the other side moving, that will be collected through this particular drain. In general, 15 centimeter diameter of the drain pipe, not more than the 300 meters length is quite sufficient. There are the different types of the pipes for subdrain. Metal, concrete, vertified clay pipe. The perforated area should be placed adjacent to the soil only. Then the water coming through the soil will be collected through this particular pipe. Bell and spigot pipe is laid with the joints are open. The water is going to be percolated through this open joint through the bell and spigot pipes. These are made with the vertified clay, cast iron and plain concrete. Porous concrete pipes collect water by seepage through the concrete. wall of the concrete wall of the pipe. You can observe here there is a perforated area around the pipe wall. This type of pipe is laid with the scaled joints. Here the pipe is not projected at the end. There is a inside reduction in diameter is there. The reduction of thickness is provided for scale joints. And skip pipe is manufactured from the both vertified clay iron is a special type of bell spigot joint. Bell spigot joints are going to be placed with the slots at the bells. So, filter materials is also very important. The criteria to be developed in selection of filter material to prevent clogging of perforated pipe with the filter and to prevent the movement of the particles from the protected soil into the filter material, to permit free water to reach the pipe and to prevent the segregation of filter material. So, to prevent clogging of filter material, perforated pipe with the filter, so the condition is to be satisfied is 85% of size of filter material divided by diameter of the perforation should be greater than or equal to 1.5. To prevent movement of particles from the protected soil into the filter material, that is 15% of size of filter material divided by 85% of size of protected soil should be less than or equal to 5, and 50% of size of filter material divided by 50% of size of protected soil should be less than or equal to 25. To permit free water to reach the pipe is the ratio of 15% of size of filter material and 15% of size of protected soil should be greater than or equal to 5. To prevent segregation of filter material, 60% of size of filter material divided by 10% of size of filter material should be less than or equal to 20. So, today we have seen what are the functions of subsurface drainage and design of base course material and design of drain for subgrade and intercepting drain and different types of materials used and the criteria for filter material. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.